In this video, we're going to take a look at some basic probability concepts. So we'll start with a few definitions. In probability, the sample space is the set of all possible outcomes. And in a related definition, the complement of an event A denoted by A prime is the subset of outcomes that are not a part of event A. So, what does all of that mean? Let's go ahead and take a look at a pretty straightforward example here, just to make sure we understand what we mean by the sample space and by the complement. So, for example, roll a 6-sided die. If we roll a 6-sided die, then the sample space, the sample space is 1, 2, 3, 4, 5, and 6. So this is our sample space here, right? Because when you roll a 6-sided die, these are the possible outcomes. You either get a 1, 2, 3, 4, 5, or 6. Let's suppose the event A is rolling a number greater than 2. What does that mean? Well, that means A is the set 3, 4, 5, and 6. And so what is A prime? What is the complement of A? Well, if A is rolling a number greater than 2, then the complement of that is rolling a number equal or less than 2. Or in other words, if we have the sample space 1, 2, 3, 4, 5, and 6, in fact, let's just go ahead and use set notation here. If we have this sample space, which has those 6 values, and A is 3, 4, 5, and 6, what is A complement? Well, that's everything else, right? That's 1 and 2. And that's how simple the idea of a sample space and the complement of an event is. Let's do some more definitions, though. 2 events are mutually exclusive if they cannot happen at the same time. Mutually exclusive. So what does that mean? That means that if you have one event and its possibilities are something like 3, 4, 5, and 6, and we have another event where its possibilities are 1 and 2, well, these events can never occur at the same time. No matter what we choose from our sample space, we could never have both of these events occurring at the same time. In fact, as we see here, if we have the complement of a set and its complement are always mutually exclusive. All right. So besides this definition of mutually exclusive, a set of events are collectively exhaustive if one of the two events must occur. Again, in our example of a event and its complement, this happens here as well. No matter what we choose, 1, 2, 3, 4, 5, or 6, so anything from the sample space, it must either be in A or in A prime. So either in the event or its complement. And in fact, always, if we have an event and its complement, those two sets are always collectively exhaustive and mutually exclusive. Just a few more a few more definitions here. So some types of probability. A priori refers to the probability of an outcome is known based on prior knowledge. For example, So, for example, the dice, as the dice example, right? We know what the probabilities are based on prior knowledge. So if we have a fair six-sided die, we know the probability of rolling a 1 is 1 out of 6, and so on. Empirical probability is the probability is based on observed data. Maybe there is an underlying condition that we don't know the true values or information of or related to, but if we see, for example, a certain illness shows up in 0.5% of people, then we would say that that is an empirical probability. So that probability is just something that we have observed based on, or that we have observed in data. But we don't know the underlying characteristics to really say of that illness to really say that it occurs 0.5% of the time. We only know that based on our data that we have collected, that is what happens. So in an event like that, or in a case like that, that is empirical probability. There's actually another type of probability as well called subjective probability, and that's based on a person's experience, but that is not useful in formal situations, so I'm not going to write that down here. But these two are useful in formal situations, i.e., you can actually make determinations based on these kinds of probabilities and get useful information from that. Okay. A few more definitions, even more definitions. We're at the beginning of a chapter here. So the simple probability is the probability of a simple event A in which each outcome is equally likely to occur. So again, our example of the dice earlier, as long as it is a fair six-sided dice. And the probability of a simple event is P of A. So we'll also get introduced to our notation. If we see P of A, that means the probability of the event A is equal to X divided by T, where X is the number of outcomes in event A, and T is the total number of total possible outcomes. In other words, what is the probability that event A occurs? And A earlier was the probability that we roll higher than a 2 or greater than a 2. So that would be 3, 4, 5, or 6. Well, the probability of that is 2/3 or 0.667, right? Or 66.7%. Because we have 3, 4, 5, and 6, that is 4 possible outcomes out of a total of 6 possible outcomes. All right. So, another definition here, joint probability is the probability of an occurrence involving 2 or more events. Oop. So we might look at a set of data. Let's do a look at a set of data that will help us explain what joint probability is a little better. Suppose we have a set of data of people that go into a store, and some certain people bought a TV, and some people bought a computer, some people bought neither, some people bought both. So if we survey 400 total people, and maybe 75 of these people both bought a TV and bought a computer, 150 of these people bought a computer but did not buy a TV, which would give us a total of 225 that bought a computer. And let's suppose that out of those 400 people, 125 bought a TV but not a computer, and then 50 bought neither a TV nor a computer. So total here, that gives us 175 that did not buy a computer. Totals down this column, 75 and 125 is 200 that did buy a TV, 200 that did not buy a TV, and again, this gives us a total of 400 people that we surveyed. So let's ask some example questions based on this. Example 1 here, or maybe 2 if we're counting the earlier example as 1. Here is a simple event. What is the probability a person bought a computer? Well, this is the probability of, what is the probability of the event capital A, that a person bought a computer. So the probability of this event, well, this is a simple event. So to do the calculation, we just take the number of outcomes where somebody bought a computer. So bought a computer, that is 175. Out of the, looking at the wrong thing. Bought a computer, yes, here was 225. Out of the total number of people surveyed, which was 400. So this is 225 over 400, which reduces to 9/16, or in other words, 0.5625, or 56.25%. So here's an example of the probability of a simple event. Let's do example 2, which is the probability of a joint event. What is the probability a person purchased a computer and a TV? Well, maybe event A is purchased a computer and event B is purchased a TV. Then, so we'll call this A, and purchased a TV is event B. So the probability of A and B is the notation we will use for that. And what is that? Well, if we look back up here, the probability that both occurred is 75 out of 400. Or in other words, 3/16, which is 0.1875, or 18.75%. And that is how we calculate some of our basic probabilities. We do have more on this, but we'll discuss that in the next video.